ఇప్పుడు చూడు. Now we will go for model analysis. Yeah, workspace. ఒక workspace లో you can create any number of analysis systems. See, we are creating. This is one analysis system. This is another analysis system. Likewise, you can create any number of analysis systems in a given workspace. Okay. Assume you need not open separate projects, but be careful. If it gets corrupted, everything will be corrupted. So you should be careful in that sense when you are creating multiple analysis systems in the same project. Okay. Now in the same workspace. Okay. So in this project, I am going to go with regular steel structure for the bicycle frame. Okay, I'm going to do a model analysis on the bicycle frame. Model analysis. In model analysis, we are actually going to obtain the mode shapes. Okay, basically mode shapes means the way in which the deformation happens in the structure at natural frequencies, or the shape at the places or the deformation states where the deformation is maximum is nothing but your mode shape. Okay, or the rest, it is the frequency is a displacement profile at the natural frequency of that particular body. Okay, so I'm going to say import external geometry file. Okay, I'm going to use bicycle frame. Open. Okay, I have downloaded this from the GrabGAD website, so you can actually get the same file from GrabGAD. Okay, now here is the bicycle frame. Okay, as you know, here will be having the front wheel support here in this particular region. So what I'm going to do is I'm going to fix the inner cylinders of this region. Okay, and yes, back wheel will be hinged to this particular place. Okay, so I'm going to fix these two regions. Okay, inner regions. Okay, model analysis is the place where in model analysis the most important thing is there will not be any surface loads, point and surface loads. That means only the displacement boundary conditions will be there. Displacement also most generally the fixed boundary conditions where you are fixing. It is the frequency, natural frequency you are going to get it when there is a frequency basically of the body at which have maximum amplitude when no external load is acting. When no external load is acting. So when you are doing a model analysis, you are going to take care that there will be no external load. So only displacement boundary conditions are the conditions which are going to be applied here in this particular scenario. So model analysis. Okay, if you look at here, right click and say insert, you can see here only displacement boundary conditions are existing. We have cylindrical support and also fixed support. Okay, so what I'm going to do is initially I'm going to go with the mesh and say update. I will go with the default mesh that is going to come. Yes, here is the default mesh. Okay, so we have the meshing done here. This is a complete solid. Okay, structural steel by default, as I said. And here, what I'm going to do is this particular region is going to be fixed. So right click, insert, fixed support. Okay, and again, so basically we have applied all the necessary things. I want the first 6 natural frequencies. So first max modes to extract is 6. Suppose you want 10, you can go for 10 here. Okay, you can even limit the search range. Okay, I don't want to limit. If we say limit the search range, what is the minimum range and what is the maximum? I don't want to limit it as such, so I'll just say no. Okay. I'm not going to have any damping here. Okay. So yes, if you want to include any rotor dynamic controls like Coriolis component and other things, if you have some sliding members and other things, yes, then you can go with that. But yes, right now nothing. So I'll just say right click on the model analysis and just say solve. We'll wait for the solution to complete. Yes, the solution is complete. Okay, now go to the solution. You can see here, okay, more shapes that are existing. Right click. You can see here all the natural frequencies are very near. That means there is some unconstrained uh, solution that is existing. We need to check that. Okay, so create mode shape analysis. So mode shape results. Once you have created mode shape results, right click, say evaluate all results. Okay, first deformation. You can see here total deformation. Everything is happening at 161 hertz. Okay, now, okay, I want the frequency response of this. Supposing that there is some load here and this is being subjected to some load undulations or some other external frequency. Yeah, I actually added an electric motor to this. The electric motor is capable of taking it to a very high speed. Okay, so now that means there is some other excitations that are coming. And the electric motor directly connects to the wheel axle, so there will be a frequency that will be coming here somewhere near to this particular rear axle or so. So what I'm going to do is I need a harmonic response. That is when this particular uh, body is subjected to an external vibration. Okay, then how will the response of this be? This inharmonic response, the I just dragged and dropped onto the solution. Prior to doing this harmonic response, you should complete the model analysis. You cannot directly go with harmonic response. Okay. Here, what you are doing is supposing that you have a body in which there are some fixed members, okay, and you are actually exciting this particular body, okay, how will the vibration response of this particular body be is of point of interest. That means, for example, let us say in this particular case I'm not going to fix it here. Okay, I have an electric motor that is fixed in this particular region. Okay, so the vibrations are the place of excitation. What is the place of excitation? This is the place of excitation. Okay, this is the place of excitation. So insert uh, as a modal analysis, insert fixed support. Okay, all the vibrations will go to this body. Okay, from this fixed support only in harmonic response. That means, let us say I am trying to study the vibrations range. I'm going to study the excitation range from 0 to 200 Hz. What happens here in harmonic analysis is, and this particular frequency fixed support, the excitations will be given. Okay, excitations will be given in this particular fixed support region. And gradually, what happens is how exactly the response of this body will be, it will be computed. Okay, that means if you are actually working on transferring a road undulations, yes, the vibrations directly go to this region and this region. Okay, but if you are trying to transfer some more motor vibrations, the motor vibrations, where will they go? They will go to this particular fixed support. Okay, so what is here? All you need to do is prior to this in harmonic response, you will also be giving the other loads. Like for example, here the person is sitting. Okay, the person load will be coming here. Right click, say insert force. Okay, let us say 70 kg person is riding this particular vehicle. Okay, or bicycle. So 70 kg in the negative z direction. 70 into 10 or minus 700 newtons is the force that is going to act downwards. Okay. Now in this well, the 70 of this 70 kgs, well, let us say some minus 500 newtons here, and the extra 200 newtons is going to come in this on this particular leg. Is going to catch the handlebar, right? So there is, let us say, 20 kg force is exerting. Okay. So yes, right click, say insert force vector uh, components minus 200. Okay, and here also force, so this force also, let us change it to components only. Okay, minus 500. Okay, now first initially uh, well, I need to go with up to 200 hertz. Okay, solution intervals is often, that means 0 hertz, 10 hertz, 20 hertz, 30 hertz, like that excitation will be taken. Now, yes, I'll just say solve. Okay, first I'll solve the model analysis. Okay, uh, okay, you can see here 30, 30, 33 means very much near, means there should be some mistake in the fixed means maybe a little more fixed boundary conditions are required here. So first initially, yeah, you can see here, as basically we need to introduce this support also, but since I am interested only in the effect of the motor vibrations, I'm not going to introduce those conditions, so we'll definitely get that warning. And yeah, what is the up to 200 hertz I want to study? So what I'm going to do is right click, say solve. Okay, so yes, here the problem is, here there are certain natural frequencies which are existing. Okay, in harmonic analysis, we gave it in steps of say 10. That means exactly at these particular natural frequencies. Okay, harmonic analysis is not, harmonic response is not performing any analysis. That will come as a warning for you. You can safely ignore that warning. Then go to insert. Okay, what is it that we need actually? We need the displacement. Okay, we need displacement. So go to insert displacement. Sorry, I need a result, right? So we don't want this. I'll again say where generated data. I'll again resolve. I by mistake, instead of plotting it, I actually try to give a displacement extra. So we don't want that displacement. Right click, now insert. We actually want a, okay, directional deformation. Yes, x-axis. You can ignore that warning. Evaluate all results. Now, yes, you can see how at various frequencies it is there. You can say, go to, you can select all this, right? You can say create results. And the directional information now, right? Uh, yes, at 20 hertz, you can see how exactly, okay, for the given excitation, how the frame is behaving, what is the maximum displacement that is coming, you can see here in x direction. Now I want actually a probe kind of thing. So what I will do is, uh, probe, not probe, wait. Frequency response, yes. I actually want the frequency response, so I want say deformation. Okay, geometry, I'll go for the body, apply, use average. What is the one we want? Yes, x-axis, y-axis, and z-axis. Suppose let us say x-axis. Right here. Evaluate all results. Here are minimum amplitude and maximum amplitude that is coming. Amplitude and phase angle we are coming. We want amplitude. Yes, you can see here. At two places you have a larger amplitude. That H one is at 40 Hz and the other one is at 160 Hz. Okay. Similarly, you can create for X, Y, and Z. Okay. Similarly, you can even plot the response for okay other cases also, like stresses, frequency response. Here we taken as a this one insert frequency response. I will take stress. I will take the total body, and I will say apply normal stress. Okay, normal stress. Okay, x-axis, y-axis, z-axis. Yes, and say right click, evaluate all results. Okay, then remove the phase angle. Yeah, maximum stress is quite less, right? Okay, I can go with the other directions also. Okay, it completely we actually need to what we need to do here is in x direction, y direction, z direction. All the three cases we need to take and we need to study. That's for you to take those particular plots. Okay, so yeah, with this we complete the harmonic response.